So we have, again, we're finding y prime. So y prime is question mark. So again, it's the derivative of every term with respect to x. So this is going to be
d over dx.
d dx of x squared minus d dx of 4xy plus d dx of y squared is equal to d dx of 4. So the first term, remember, when we're differentiating with respect to x, and we have an x, and only an x, we don't have a problem. So the derivative of x squared is 2x.
Okay.
Now the second term, product rule, okay? Because this is the derivative of, with respect to x, of 4x times y. So it's a product rule here. So when you differentiate this, you have the derivative of the first function, the derivative of d dx, I'm sorry, the derivative with respect to x of 4x is 4, right?
Mm-hmm.
Then you multiply that by y, the second function. So the derivative of the first times the second plus the first, which is 4x, times the derivative of the second, which is dy dx. So remember, we're subtracting that. So it's 2x minus the quantity negative, 2x minus 4y plus 4x dy dx. Then I have to differentiate y squared with respect to x. So I get 2y, because I differentiated like normal. Then I treat y as a function of x. So by the chain rule, I have dy dx. 2y dy dx. And then d dx of 4, again, because the derivative of any constant is 0, you get 0. So I have 2x minus, open parenthesis, 4y plus 4x dy dx plus 2y dy dx is equal to 0.
Okay.
Okay? Now I have to clean this up, and I have to isolate dy dx. So I have 2x minus 4y minus 4x dy dx plus 2y dy dx is equal to 0. Now what I'm going to do is I'm going to keep the terms with dy dx on the left side, and I'm going to move the other terms over. So I'm going to write them in a different order. I'm going to say 2y dy dx minus 4x dy dx equals 4y, because it was negative on the left, it becomes positive, minus 2x. Now I'm going to factor out dy dx from the left side. So I have 2y minus 4x, in parenthesis, 2y minus 4x in parenthesis, times dy dx equals 4y minus 2x. And so dy dx is going to be 4y minus 2x over 2y minus 4x, and then I can factor out. So dy dx, if I factor let's see, I don't know if I want a negative or a positive. Let's factor a negative from the top. So I have, well, actually, I can factor a positive, I guess, because they're both negative down here. So if I factor a positive 2 from the top, I get 2 times 2y minus x and 2 times y minus 2x. The 2's cancel, and so I get dy dx is equal to 2y minus x over y minus 2x.
Okay.
2y minus x over y minus 2x. Two y minus x over y minus 2x. Yeah, I'm not sure how far they wanted you to go. We'll see.
Yeah, that's right.
I mean, there's a couple of different ways to write that answer. That's the only reason I said that.
Yeah, I think they take like a lot of different ways, which is good.
Yeah, Pearson gives you 100,000 directions about how they want it.
Yeah.
X squared over x plus y equals y squared plus 6. Okay, so now this is going to be a little bit trickier. So we're going to do it, start the same way. D dx of the fraction x squared over x plus y is equal to d dx of y squared plus d dx of 6. Now, this first fraction is going to be quite a quotient here. We have to use quotient rule with the chain rule. So when I differentiate this, I have, first I write the denominator. So I have parenthesis x plus y times the derivative with respect to x of the numerator, x squared. So parenthesis x plus y times d dx of x squared minus x squared times the derivative with respect to x, open parenthesis, of x plus y, all over quantity x plus y squared. Okay, so that's just the first term. Equals d dx of y squared is 2y dy dx, and d dx of 6 is 0. So I'm just going to leave it off. Okay, so on the left I have right now, I have a big complex fraction. On the top I have the quantity x plus y times d dx of x squared minus x squared times d dx of x plus y over x plus y quantity squared equals 2y dy dx. Now, before I can solve for dy dx, I have to take my derivatives. So on the left side, I have x plus y. The derivative with respect to x of x squared is 2x. So basically, I have parenthesis x plus y times 2x minus x squared. Now, the next part of this is the derivative with respect to x of x plus y. Well, that just means I'm adding two derivatives. So d dx of x is 1. So I have x squared, and I open a parenthesis, and I have 1 because d dx of x is 1. And d dx of y is dy dx. So that's the top.
So it's
The bottom,
1 plus dy dx.
right,
Okay.
all multiplied by negative
X
x
squared.
squared over x plus y squared. And that's equal to 2y dy dx. Now I have to I can help myself a little bit if I multiply out some stuff.
Okay.
In this case, I'm gonna leave the bottom in factor form. I think the first thing I'm gonna do before I multiply the top is I'm gonna multiply both sides of the equation by x plus y squared.
Okay.
So because I know that's gonna be a positive answer, and so it's not gonna be a huge problem for me. So I'm going to go ahead and say, well, that's going to leave me with 2x, open parenthesis, x plus y, minus x squared, minus x squared dy dx. I went ahead and distributed that one.
Okay.
I could have distributed the first one too, but, and I will eventually, but I just think it's easier to write it if you see it. Then here on the right side, I'm just going to leave it for now as 2y dy dx times x plus y squared.
Okay.
I'm not going to FOIL that because I need to isolate the dy dx anyway.
Yeah.
So the coefficient on the right side of that dy dx is everything else over there. So I'm not going to bother distributing it because I'm going to end up dividing by it anyway.
Okay.
What I will do is I'm going to finish multiplying on the left,
Mm-hmm.
and I'm going to move the negative x squared dy dx that's on the left to the right side. So I'm going to have 2x times x is 2x squared. 2x times y is 2xy minus x squared. And then I'm going to write the right hand, then I'm going to say equals, and I'm going to write the right hand side as x squared dy dx. And I'm just going to rearrange the other term. So I'm going to have plus 2y times x plus y squared dy dx. So then, now I have to factor out dy dx. So on the right side, I'm going to factor out dy dx, and I'm going to use a bracket. I'm going to end up with x squared plus 2y times x plus y squared. And then I'm going to write the left side just like it is. And all I'm going to do is divide by that term that I just factored out of dy dx. So dy dx will equal 2x squared minus 2xy minus x squared all over x squared plus 2y times x plus y quantity squared. And oh, I just noticed something. 2x squared minus x squared on the top, they're like terms. I didn't see that. You see that?
Yeah.
So actually I end up with x squared minus 2xy on top. And I can factor that if I want to. I'm not sure that it helps me, but I could. X squared plus 2y x plus y squared. So that would give me, if I factor on top, I would get x open parenthesis x minus 2y over x squared plus 2y times x plus y squared. Yeah, I didn't see that those canceled, but they do.
So basically it's x parentheses x minus 2y
Uh-huh.
all
Close
over x squared plus 2y times the x plus y squared.
Yep, that's what I have.
Okay. So you
That's
basically just moved those things over and put it under. And that's
right. Uh-huh.
okay.
Yeah, the last step is to divide by the coefficient of dy dx.
Yeah.
Close parenthesis on top. There you go. Open parent. No, it has to be a parent. Okay.
Oh,
That's fine. I always
okay.
forget that do you have to put a dot on top too?
Yeah, I don't know. Sometimes it takes it like that, and sometimes it takes, I don't know. It probably takes it either way, and I just
I just wondered because I remember asking you that the other, but it might be one of those
Yeah.
things where it depends on the programming of it.
Yeah, because sometimes I put it and sometimes I don't.
Oops, did we miss something? X squared, or did it not go in yet?
Yeah, it didn't work that way.
Hold on, X, did I miss something? Let me see. X, let me check it and see if I
Okay.
missed
Let
a
me just grab some coffee. I'll be right back.
squared over X plus Y equals Y squared plus 6. So, okay, so we get that. X plus Y dy dx So g times the derivative of f minus f times the derivative of g with respect to x, okay, over g squared then this is 2x times that minus x squared minus x squared dy dx, okay, equals 2y oh, I think I see what I did. I think I see what happened. So 2y okay, this doesn't have, that's why. It's only this that has dy dx on it, this thing. So then let me see. So this is gonna be 2x. Let's see what we have here. I think where I made the error was minus x squared minus x squared dy dx over x plus y squared. X plus y squared equals 2y dy dx. And that was, well, yeah, so 2y dy dx. So then I need to do 2x squared plus 2xy minus x squared minus x squared dy dx over x plus y squared. And if I want to isolate that, then this is going to be 2y dy dx. So this has to stay together. So when this multiplies here, then I have, I think that's where I went wrong. The coefficient of this is just 2y, not that. So I have 2x squared minus x squared is x squared plus 2xy 2xy okay 2xy minus x squared dy dx equals 2 dy dx times x y squared.
Okay.
So then if I move this over, I have x squared plus 2xy equals 2y dy dx times x plus y squared. I think what I did when I multiplied by x plus y squared is I made it a coefficient of dy dx. I mean, I made it a factor of dy dx. And
I was actually wondering about that. when you did that.
It's just a coefficient. I mean, it's still legal, but I can't factor dy dx out of it. I just have to divide by it. I'm seeing what I get: 2y dy dx
Okay.
times x plus y squared. So then, where am I here? Oh, I was gonna move this over. That's right. Minus x squared dy dx. So then I get, let's see if I can isolate the, but what am I gonna do with that term? X squared plus 2xy.
Sorry, I need to grab my glasses. I'll be right back.
Uh-huh. X squared plus 2xy. Oh, maybe I have to distribute that. Because this would be a bunch of terms in that case. Just still work though. Let's move on, and I'll do it later
Okay.
because I don't want to bog down doing it.
Okay.
I'll look at it. I'm sure it must be some algebra mistake that I made somewhere. X plus y squared, unless it's on the bottom somewhere. Let me yeah, let me move on from there. See what I did. Okay.
Because from my understanding, I'm not sure if it applies here, but aren't we supposed to also multiply by the derivative of what's inside the parentheses as well?
Inside.
Like from the very beginning, you know how we did the quotient rule?
Yeah, so
And then aren't you supposed to, because he always says like you want to multiply by the junk or whatever, but that's only if you had like something inside the parentheses.
okay, so are you, what step are you talking about?
When you do the quotient rule.
So gonna be it's gonna be x plus y
Mm-hmm.
times the derivative with respect to x of x squared, which is 2x,
Yeah.
minus x squared times the
Um,
derivative of x plus y with respect to x. That derivative is 1 plus dy dx.
okay, so like the top part where you have x squared and then you do the derivative of x plus y.
Uh-huh.
Sometimes I'm I'm not sure if this is like the same thing, but he multiplies again by the actual what's inside that parentheses. So like he would multiply.
It's not a, but it's not a product. It's not a product. It's the derivative of a sum. You're talking about the product rule, but you're doing the
Like the chain rule where you have to multiply the stuff inside as a derivative.
that's what the
It's
because it's
Yeah, it's not the product rule, but it's like the chain rule.
that's why we got dy dx from. Otherwise, we would just get 1 plus 1 because x squared was the numerator.
Yeah.
So the denominator, you write it like it is.
Hmm.
You take the derivative of the numerator, which is the derivative of x squared, that's 2x,
Yeah.
you subtract the numerator, x squared, multiplied by the derivative of the denominator, with respect to x. So the derivative of the denominator with respect to x is not a product, it's a sum. So the derivative of x with respect to x is 1, and the derivative with respect to x of y is dy dx.
Hmm. Oh, I see. So then it would then become x squared plus x
Negative
squared,
x squared minus,
negative x squared,
because it's minus x squared dy dx.
and then it's negative x squared of dy dx.
Uh-huh.
So do you then take the derivative because of the x squared right there and become 2x? Or no?
No, it just means that
It
you're
just,
multiplying. No, because if I were taking the derivative, it would be in front of it. This means x squared times the derivative dy dx.
okay. And you don't take the derivative of the bottom, the x plus y squared?
No, the quotient rule
Mm-hmm.
doesn't say it's low d high, right? Low d
Yeah.
high
Oh, okay. So it's
minus
just
high d
following.
low over low low. There's
Yeah.
no derivatives on the bottom.
Okay.
I messed up the algebra somehow. I just don't know how yet. but that's and then the derivative of y squared is 2y dy dx. Unless I were to get a if I try to
It could also be like the format that I have it in. Maybe.
well, you can try reading it or watching it and seeing if that happens. But
Yeah.
I don't think I see anything wrong with it.
Because then you have 2x squared minus x squared, which becomes x squared.
Let me try moving the y squared over and getting a common denominator first and see if I get a different answer from that. X
Okay.
squared. I should get the same, like an equivalent version of it, but let me see if that helps me find the mistake. X squared
Okay.
times x plus y minus y squared over 1 is equal to 6. So then I get, let's see, I'm going to go ahead and multiply. I mean, not multiply, but get a common denominator. So that's x squared. And this, I need to make this x plus y. So this is going to be minus y squared times x plus y over x plus y is equal to 6. And then I get x plus y. So this is x squared minus x squared y minus y cubed is equal to 6. So then I do the derivative, which is going to be a lot nastier, but it's going to be x plus y times the derivative with respect to x of all three of those terms, which is going to be a mess. So we have 2x, and then I have product rule, so I have minus. Okay, so first function is 2x times dy dx plus the second function y. Derivative of the first. Oh wait, I messed this up when I wrote it. So it's x plus y times 2x minus, then I have to do the product rule. So it's first function, which is x squared dy dx, plus the second function times the derivative of the first.
I think that x squared's supposed to be. Oh no, no, it's added. Never mind.
Minus 2x. Did I get all four? Let's see. Yeah, I did. Okay. Then I have to do, so this is going to be that product there. And then, so that's my first function times the second times the derivative of the first. That's my bracket. And that's my parenthesis. Okay. So then I have minus 3y squared dy dx over x plus y squared. So then I have, let's see, we have x plus y times 2x minus x squared dy dx
No,
plus 2xy minus 3y squared dy dx. This is 0, by the way. Over x plus y squared. And I can drop one of these because they cancel. And then I have, let's see what I have. I have, let's see here, like that. 2x minus x squared dy dx plus 2xy minus 3y squared dy dx over x plus y is equal to 0. So then, if I factor out, well, let me write this as 2x plus 2xy then I factor out a negative. From there, I get x squared dy dx plus 3y squared dy dx over x plus y. And then this, oh, I can cancel again. I didn't realize that. So this is going to be, okay, that's equal to 0. So then, if I multiply this by x plus y, then I have 2x plus 2xy minus actually equals, because that's going to go over there now, equals 2x plus 2xy. So it's going to equal x squared dy dx plus 3y squared dy dx. And then I have, so then I have 2x plus 2xy over x squared plus 3y squared. And that's equal to, and then that's going to equal, that's going to equal, if I factor out 2x, then I have 1 plus y over 2x here. 2x times 1 plus y over x squared plus 3y squared. Okay, so now I'm getting something different. But come back to that because I need to check this before I give it to you to make sure it's, but I'm getting something different than the answer that I got before. And I'm not sure if it's, I'm not sure what I'm doing wrong. But let's do number 4. So it says y cosine x is equal to 2x squared plus 3y squared. Okay, so then you multiply to get your derivative on the left, product rule. So it's derivative of the second function. So the derivative of cosine is negative sine x times the first. So y, negative y sine x negative y sine x, then plus, so
You're doing the product rule.
yeah, right. First function times the derivative of the second one plus the second one
Cos x.
times the derivative of the first one. So cosine x times dy dx is equal to, now here I just apply the power rule and the sum. So we have 4x squared,
Or is it just 4x?
4x, sorry, 4x, yeah, 4x. And then here we get plus 6y dy dx. So now,
And the reason you applied it to the second one and not the first one?
I don't need the chain rule on the first one because
Okay.
I'm differentiating with respect to x, remember.
You're right.
So I could apply the chain rule if you want. You'd apply the power rule, so you get 4x.
Mm-hmm.
And then the derivative with respect to x of x is 1.
1.
So you get 4x times 1, which is 4x.
Okay.
When you do it with the y with respect to x, you get 6y times the derivative of y with respect to x,
Okay.
which is dy dx. So we did apply the chain rule. We just didn't write it. So we have negative y sine x plus cosine x dy dx equals 4x plus 6y dy dx.
Mm-hmm.
And so I'm going to move the dy dx terms together and pull everything else. So I'm going to move the dy dx terms to the right and pull the 4x.
To the left.
Actually, I could, but let me try to keep negatives out of my life. So I'm gonna leave the cosine where it is, the cosine x dy dx.
Okay.
Move the 6y dy dx.
Okay.
And move the negative y sine x. So I'm gonna get cosine x dy dx minus 6y dy dx equals 4x
4x
plus y sine x.
y sine x.
Okay?
Okay.
Then I'm going to factor out dy dx. And I'm going to get cosine x minus 6y is equal to 4x plus y sine x. Now dy dx is going to equal 4x plus y sine x over cosine x minus 6y.
Okay.
That's not so hard to enter.
Yeah.
The other one that we had. I'll have to look at that because I just did the other one 3 times and I got a different answer every time.
Oh my gosh.
So maybe I'll text Professor Nick Dell later and be like, "Can you help me find the mistake?" Because I'll be looking at it for the next. No, I'll try to do it again later, and then I'll just text you and be like, "Is this okay?" Or did I? Because the answer they aren't taking it, so I think there's something wrong.
Mm-hmm. I could also I could check it too.
No, it's just a matter of I just want to at this point, like I just want to know.
Yeah.
I don't like I just want to know what the answer is. One of those issues, like I don't even care if it's right or wrong or what. I just want to know what's the answer supposed to be.
Mm-hmm.
So does that make sense? Did you understand that?
Yeah.
Okay.
Yeah, they're not too bad.
No, they usually aren't. There's usually one or two that are kind of sticky. But now this one is going to involve the chain rule, not the product rule.
Okay.
Well, it will involve the product rule when we take the derivative of the inside. Because notice the argument of the cosine is a product.
Mm-hmm.
So we're going to have to use the chain rule. And when we apply the chain rule, we have to apply the product rule. Okay. So we have cosine of xy equals 1 plus the sine of y. So this gives me, so first of all, the derivative of cosine is the negative sine, and you're going to write the argument again. Negative sine of xy, okay? Then you're going to differentiate the argument. So we're going to have to differentiate the argument, which is xy. So we have x dy dx plus y times 1, because first function x times derivative of y with respect to x plus the second function y times the derivative of x with respect to x, 1, okay? Equals, the derivative of 1 is 0, okay? So 0 plus the derivative of sine y with respect to x, the derivative of sine is cosine. So we have cosine y times dy dx. Okay?
Okay, can you explain again that X and Y part?
The one on the left side?
Yeah, how did the Y become 1 again?
No, okay, so
Oh,
first you differentiate the cosine,
okay,
which is the negative sign. You write the argument just like it is. So negative sine xy.
okay,
And then maybe on the side of your paper somewhere, write the product xy and differentiate it with respect to x. So your first function is x, your second function is y. The derivative of x with respect to x is 1.
okay,
The derivative of y with respect to x is dy dx.
okay.
Okay? So that means when you write the product here, you have the first function, x, times the derivative of the second function, y, so x dy dx, plus the second function y times the derivative of x with respect to x, which is 1.
Mhm.
So here, let me, let's see. Let me see if I can do. I didn't finish
So
the.
basically the Y is getting multiplied to the D and then it's becoming dy dx. That's what
Well, it's you're not multiplying it; it's an integrator.
okay.
I mean a differentiator. Sorry. Um, 9. It's a function, not a product. 6, 9. So so when you okay, so if I have, let me do this here. Let me stop sharing your screen. Well, let me pull up Google first and see if I can help us. So, so let me now share this. And share Google. So now this is going to be, okay, so the problem that we have is we have we have um we
Cos.
have cos no we have y cosine x, y cosine x.
I thought it was cos and then x, y in the parentheses.
Wait, what did I start with? Y. Is it cosine xy or is it?
Here, let
Did
me
I
look
wrote
at it.
something different down? Maybe I'm
Maybe.
looking at the wrong one.
Maybe that's why.
Oh, I'm looking at number 4. Okay. No,
Yeah,
no.
it's
I
cos.
was, I was looking at number 4. No, I did the problem, but I was
Oh,
pressing the wrong one. So
okay.
I did them both. I was looking at number 4, like, where's the rest of it? You didn't do the rest of it yet. That's y is not there. Plus the sine of y. Okay, so we're here, right?
Yes. Mhm.
Okay, so here we have this. Now, let me see if I have my add-on. See if this actually, sometimes this is helpful. We'll see if it works.
I know it's too bad you can't like speak to text or whatever.
Well, yeah, I can, but the thing is, math symbols. But I have this really clunky equation editor in
Yeah.
Google Docs, and but it takes forever to paste everything in there.
Mm.
So okay, so we have cosine xy plus 1 plus the sine of y. So when I use the chain rule here
Mhm.
okay, so let's look at this. So for cosine xy, okay, my outer function is cosine. If you want to call it, let's say my outer function is u, right? Or I can, well, let me write it like, before I write that, let me write this. So the chain rule says dy dx equals dy du times du dx, right? So y is a function of u, and u is a function of x. So y is a function of x, and my du is my inner function. This is from yesterday, right?
Yeah.
So then I can write this as my outside function. If I just have f, big F, is equal to the cosine of xy, right? Then this is the product of two functions, okay? Call them g of x. Now g of x is my outside function, which is cosine x, okay? G of x is cosine x. Cosine x, there we go. And h of x is, actually it's in two variables. H of x is xy, okay? That's not exactly correct notation, but that's essentially where we're going with this, okay? So then f of x, f is equal to f of g of x. And that means that you're doing the outside function, which is, actually I changed my,
Variables. Yeah.
there you go. So this is cosine x, but it's cosine of this inside part, xy, right?
Mm-hmm.
So I have to differentiate the outside. Now, this is where you're getting tripped up. Derivative with respect to x of cosine x is negative sine x. Okay? So whatever the argument is, you just bring it over. Now, the problem for you is this. D dx of x is 1 by the power rule. d dx of x is 1. d dx of y is dy dx because the variables don't match each other. Y is a function of x.
Yeah.
So I need the, okay? So when I differentiate, if I differentiate x, y, then my first function is x. And my second function is y. Okay? Now, when I write the product rule and I differentiate x, y, the product rule says that it's the first. Now, you might have learned it the other way. You can write it as the derivative of the first times the second plus
The first.
the derivative of the second times the first, or however you learned it. I don't know how he taught it to you. I usually say first times the derivative of the second, plus the second times the derivative of the first, but it depends on how you learned it. The plus the, so the derivative of the first,
We usually do like derivative of the first times the second, and then we do the first times the derivative.
First times the derivative, okay. So see, I do it the other way. And that's probably another reason why. I do this term, I do the term after the plus first. But that's just me. That's how I learned it. So, but that's this. Okay? Derivative of the second. Why can't I type today? All right. So then, now we know what the first function is. We know what the second function is. And the derivatives are up here. So the product rule for x, y is going to be this as an implicit derivative. Is going to be derivative is going to be the derivative of the first function. So the derivative of x, I'll write it like this. The derivative of x with respect to x plus, times the second one. So we're going to multiply by the second one. The second one is y. Okay. Then you have plus the first one, x, times the derivative of the second one, d dx of y. Okay? So then you have chain rule. So d dx of x
is 1
times y
plus x dy
by dx.
Okay, that makes sense. Sorry, it wasn't clicking that we're using the product rule for this. Okay.
Now, keep in mind we haven't done the cosines, but that's just the
Yeah.
inside
The
portion.
inside.
Okay?
Mhm.
So now your actual function that you're trying to find the derivative of is, so, okay, so we did the hard part, right? I hope we did the hard part. Maybe not, but I'm hoping. So now, if I'm looking at find the implicit derivative of let's say f equals the cosine of xy. Okay. Then what I'm going to have to do by the chain rule is I'm going to say f prime is equal to, first I'm going to differentiate the cosine,
Okay. It's
and get
negative.
what? That's
Negative
going to be
sign.
negative sign. Copy the argument just like it is, xy. Okay? Copy it just like it is. So there's my outside derivative, right?
Okay.
Now I'm going to differentiate times the derivative with respect to x of times the derivative with respect to x of xy. Now we did up here, so we
Yeah.
get f prime is equal to negative sign of xy
Okay.
times this derivative that we just did down here.
Uh-huh.
You see it right here.
Y
This thing.
plus
Y plus x dy
X
dx.
dy dy.
So this, now this isn't part of the argument of the sign. It's a
The inside.
multiplier.
Yeah.
So we have that.
Okay.
Okay? Is that clear?
Okay.
Is that okay?
Mm-hmm.
So then you have, let's clean this up. We have f prime is equal to, now 1 times y is y, and x dy dx is 1. So so you got 1y plus, this should be,
Isn't it dy dx what we're solving?
I made a x d dx. It should be, this should be x. This should be d dx. I typed it wrong. X d dx of y. So this is going to be, I typed it okay up here.
Oh,
It
okay.
just lost it lost the variable down here. So this is going to be, negative sign of xy times y. So this term, my product rule is this part, 1 times y plus dy dx of x, right? So this is your issue. So when you work it out, you get negative sine xy times x dy dx plus y. So negative sine of xy times x dy dx plus y, right? And so dy dx of x is 1. X dy dx this is x dy dx,
Mm-hmm.
and dy dx of y is 1. So x dy dx.
And you note that there's a second part of the function too, right?
Then, okay, that's cosine. And then I have the other side of it. But yeah, differentiating the other side is not a problem.
Okay, I just wanted to let you know, just in
Yeah,
case.
no, you're having an issue on the left.
Yeah,
This was designed to help you. You don't have a real issue on the right because that function is in terms of y.
yeah.
So it's only because this function is in terms of both. So what are you going to end up with on the left? You're going to end up with negative
Sine of x, y
sine of xy
times 1.
x dy dx. Well, x dy dx is not 1.
Oh, okay. It's not 1.
Negative sine of xy times x dy dx
Mm-hmm.
minus y sine of xy.
Oh, okay, so you're distributing.
Right.
Okay,
Is equal to the cosine of y dy dx. You see it?
so minus sine of xy times x of dy dx
Mm-hmm.
minus the sine of
Minus y sine
y sine
xy
xy.
equals cosine of y dy dx.
Okay.
Now, all I'm going to do is take, you see how I have that first term? And
Mm-hmm.
I'm going to move that first term, the one before the negative y sine y, I'm going to move that first term to the right side. So I'm going to have negative y sine of xy is equal to cosine of y dy dx plus um, sine of xy
Times x
times x dy dx.
dy dx.
Okay? So notice now that I have my dy dx in both terms. You see it?
Yeah.
So I'm going to factor out the dy dx on the right. And I'm going to end up with cosine of y. The dy dx goes away, and then I have
Plus sine.
x sine xy plus
Oh, okay.
x
Sine
sine of xy.
xy.
Now, on the left side, I have
Negative y.
negative y sine of xy. So my derivative is going to be negative y sine of xy over cosine of y plus x
Sine of xy.
sine of xy. Right?
Mm-hmm.
Does that help a little bit?
Yeah, it does. As long as I remember this. It's a different story when you're doing it alone.
Yeah, it's true. And it depends on how much you have a chance to practice and whatnot.
Yeah.
So,
Yeah, I think it's starting to make more sense though, because at first I didn't understand the concept of taking the derivative of each term, you know?
Oh, okay.
So now it's starting to make a lot more
When you're
sense.
adding, that's why in the last problem when we were adding, it wasn't the chain rule. When we
Yeah.
were doing x squared plus y squared, it wasn't the chain rule because you're just adding terms together.
Mm-hmm.
So it's the derivative of the first one plus the derivative of the second one. It's a sum. But
Yeah.
this one is a product with an implicit derivative in it. And that's why it's harder than the last one we did.
Yeah, because then you're taking the derivative, but then you're applying the product rule from the inside. Yeah.
Okay?
And then with the quotient rules, you apply the quotient rule first and then you apply the derivative after. Is that how?
Well, okay, so if we were just doing, let's say that we were just doing, instead of that horrendous one that we had, let me do, hold on, page break. Instead of doing the horrendous one that we were doing earlier, let's say that I wanted to find d dx of x over y.
Mhm.
Okay, so it's not x times y, this is x over y. Okay,
Okay.
so this will make it a little bit easier for you to see it, I think.
Okay.
So remember, this is quotient rule, clearly, right?
Yeah.
Because that's a quotient, isn't it?
Right.
So if that's a quotient, then you're going to do this. So the quotient rule says, and the quotient rule applies regardless of whatever rules you're using. So it says low times the
Derivative.
derivative with respect to x of high minus high times the derivative with respect to x of low, and all of this,
Low,
this
low.
is where my um, latex would have come in handy if I had thought of it. But anyway, um, this is going to be this, and this is going to be low times low. Now, one of the questions you asked me was, are there derivatives down here? Even if I'm using a chain rule, there aren't any derivatives at the bottom.
Right.
Okay, there aren't any derivatives at the bottom.
But it's at the top, right?
Yeah, the top has derivatives. The bottom doesn't.
Well, I mean, if you had, for example, like a chain rule, like what we just had with the sign and then the XY in the middle,
Uh-huh.
and then you had that over
And that's why
something. Yeah.
you still okay, but that would be part of the chain rule for the argument of the sign. If I had something like
Yeah.
this, sine of x over y,
Hmm.
okay, then here I would just be doing chain rule, and it would be the quotient of x y. If I had something like the sine of if I had something like the sine of xy, and I was dividing it by, say, cosine of x, then I would have the chain rule here, and I would have a quotient rule for the argument, And then I would have a quotient rule for the outside.
Mm-hmm. Okay.
Okay? So in this case, you would get something like, for just, for just the quotient rule for x over y, implicitly, you would get low, which is y, times the derivative with respect to x of x minus x times the derivative with respect to x of y. And all of that would be over y squared. You see?
Yeah.
So y times the derivative of x with respect to x is 1. So you get y times 1 minus x times the derivative with respect to x of y. So you get minus x dy dx
Mm-hmm.
all over y squared.
Yeah.
Okay? Where this one, you would get, if I did this one here,
And you would leave it like in that form
well, I would have to solve
for the
for
dy
dy
dx.
dx, remember?
Okay. Yeah.
But I didn't make it equal to anything.
Yeah.
Because I want you to practice this part.
Yeah.
But I would have to manipulate it and isolate dy dx. But I can't do that if it's not equal to anything.
Right.
If this was equal to 0, say, if this is equal to 0, right? Find d dx of x over y equals 0, then I can say, well, this is, now I have to manipulate it and solve for dy dx,
Yeah.
right? So then I have y, because y times 1 is y, right?
Mm-hmm.
Y minus x dy dx all over y squared.
You would just move the y squared, multiply it by the 0,
Right, and then you'd move
and
the
then
dy dx over.
okay. Okay, I can get it from there.
You see? But if it's something else, then you got to move the function.
Yeah.
You understand?
Yeah.
Is that better now?
Mm-hmm. Yeah, I think it gets a little bit harder when it's like a function inside of like what we just did.
Right. No,
Yeah.
that's what the chain rule is for.
Yeah.
Functions inside functions
So
are
you
what the
work
chain rule is for.
the outside first, and then the chain rule is like where you take you do the outside, you leave the inside alone, and then you multiply it by the derivative of the inside.
That's correct. Record yourself saying that about 100 times because
I know.
that was about as good as you can say it.
Okay.
Right. Take the derivative of the outside at the inside, so leave the inside alone.
Mm-hmm.
Then take the derivative of the inside and multiply it into.
Okay.
Yes. Ta-da! A good thing you don't have class today, huh?
I know. I'm just like, I think I mixed up the sections for the test. I think it's only 2.6 and 2.7, but I could be wrong. I'll have
Oh,
to
the
look
quiz?
at my notes.
The quiz, you mean?
Yeah, the quiz, I think it's 2.5 through 2.7. So,
So 3 sections. That's not so bad.
yeah. Because at first
I
I
was
was,
going to say, because like 7 sections, that's a lot.
oh,
For,
yeah, no, that's for the test next Thursday.
but he gave you
Oh.
like 4 sections for the quiz last time. So I was like, when you were making it like 7 sections, I'm like, that's a lot of sections.
Oh, yeah, no, I think he was just saying 2.5 through 2.6
Mm-hmm. Yeah.
and 2.7.
If I
So,
have a chance, I'll go back and listen to the lecture later today.
okay.
I have to make another phone call at lunchtime.
Yeah, and I think the homework, as long as we try to get through um, this one and then maybe 2.7
Well,
tomorrow.
do you think it would be easier if because what I can try to do is, um, go and go in and look at your go. So if you send it to me, then I can do it ahead of time. You know what I mean? Like you did for 1.7. You know what I mean?
Like the,
You know how in 1.7 you had difficulty with the problems, right?
uh-huh.
So you sent me the homework. Remember?
Oh, yeah, where I circled the ones.
So if you send me the homework for we did it for 1.6 except for that one, and I'll send you the solution to that today
Mm-hmm.
because I have it. I just didn't write it down because I don't know, yesterday I was like I didn't do as much as I should have yesterday because I was doing other things.
I know, same here.
But uh, if you send me 1.6, not 1.6,
2.6
2 point
or
whatever
2.5
section. 2.5, 2.6, which is
and
this one, right?
2.7.
And
Mm-hmm.
2.7, then I can send you the solutions. And maybe
Okay.
if you're looking at it at the same time that we're doing it, maybe
Yeah.
it'll make more sense. So that if you get stuck trying to do it, you can at least do it. You know what I
Yeah.
mean?
Yeah.
Um, because we did most of it yesterday.
Yeah, we did. Well, I finished the rest of it. So I finished 2.5.
Oh, nice. Okay.
Yeah.
Yeah, so send me the next 2.6 and 2.7, and
Okay.
I can work on it later.
Okay. And I wasn't sure if you're free tomorrow. Let's see,
Tomorrow
tomorrow's
Saturday? Yeah,
Saturday.
I should
Okay.
be able to. I have to talk to Doris and see what she went to class and turned in the first draft of her essay, and she said it went well.
Oh,
But
that's
she
good.
said everybody was confused. So
Okay.
I promised her I'd call her today at lunch to see what
Yeah.
we could do. But her essay is actually coming along quite well.
Oh,
So
that's
I'll
good.
have to probably, I think what she's going to have me do is listen to that professor's lecture to see what he said. So I
Yeah.
have a feeling, and I want to listen to Professor Hugin's lecture to see what he said. But I also want to take a look at your test.
Yeah.
So, so
Yeah, because I think the hard part about this class is there's only 2 tests. So it's kind of like he described it as like your 2 midterms.
I see.
So we have like test 1, test 2, and then you have the final.
And then the final. So
Yeah.
is he weighting the tests differently than the rest of the work? Or is everything weighted the same
I think the test is 20%, so it is a little bit higher of a percentage.
than the quizzes and homework?
Yeah, so your tests come out to like 40%, and then I think your final's like 30%.
Okay, so
So,
he's weighting the test. So you have to do well on the final, basically.
yeah, and I have to do well in the next test. So, yeah,
Yeah.
which is on Thursday. So, it's
Okay.
like, oh my gosh, it's tomorrow. But as long as I knock out like 3 sections this
Right.
weekend,
Right.
and then I think I'll have to check the syllabus, but I think it's till 3.2. I'm hoping.
Okay. Well, send me the homework so I can work on it. Because these
Okay.
problems are not hard, they're just long.
Yeah.
Some of them are tricky, but they're not really hard. You have to write a lot.
Yeah.
So send it to me so I can help you.
Okay.
And then I can send it back to you tomorrow and Sunday, and then you can, you know what I mean?
Okay. And I wanted to see
Uh-huh.
if you could help me also with the quiz.
Well, is
Um,
that probably, but I mean, is that like the same way we did it last time? Because I didn't remember that he did it through WebAssign last time.
yeah, this time it would be through WebAssign. So I wasn't sure if like you could be like just checking to make sure I was doing the setup right.
Yeah, but I don't know how to actually tell me how to actually like how you actually want to do that. If you want to send me screenshots, or um, are you gonna copy the problem down and then, you know
Yeah,
what I mean?
yeah, I could do it either way.
Because I don't, the thing that I don't want to have happen is like if we do it through Zoom and then my internet crashes,
Oh yeah.
you know what I mean? I don't want it to be, but I don't have a problem if you take a picture of it or whatever,
Okay.
or a
Yeah, 'cause
screenshot or something.
I don't see it posted, but
Not yet, anyway. Is it in, but it's in a different place, isn't it?
let me see. So I haven't taken a quiz here yet, so I'm not sure how I went to my assignments. Um,
Maybe they have instructions within the,
yeah, I go home. So, I mean, the only thing I could think is it would be here under home. And it doesn't have the quiz. It just has current assignments and it goes up to 3.2 for the homework.
so maybe check a little later and
Yeah.
he put it. Maybe he's still writing it. He should post an announcement when it's available, right?
Yeah, I think he would. Yeah.
Because he did that last time.
Mhm. Yeah, he's pretty good about that. So I think he'll post one. Yeah, so I'm not sure how that works if it's like a timed quiz. He didn't
Yeah, it
mention.
might be, but I don't think it's gonna be like anything like 10 minutes or something like.
Oh, okay. Yeah.
But I'm sure he's, so wait until he posts an announcement,
Okay.
and then you can, because it's not due till Monday and it's only Friday, so,
Yeah.
and Friday morning at that. So I would, give it until maybe check again at lunchtime in a couple of hours and see if he
Okay.
posted an announcement of some kind. And then, yeah, I need to look at what material is actually on it. So I'll try to go in and look at his lectures to see what he's been showing you, to see what the material is on.
Yeah. Yeah, because I know the quiz itself, he said, is going to be pulled from the homework
Oh,
because,
okay.
yeah, he said that it's best to do the homework for the quiz questions. But I think for the test, he pulls it from both.
I see.
So,
Well, then your best bet would be to send me the homework
yeah.
so I can help you with the homework. And then you can have one batch of notes with the whole, then you can just look for it
Okay.
if he's gonna pull from there. Even
Yeah.
if he changes the numbers, if you can find the example, you know what I mean? Or is it harder for you when I send you like I did for what was it, 1.6 I think, or 1.7, where I basically did all the problems that you sent me? I think I did most of them.
Yeah.
Is
Yeah.
that harder for you when I do that? Because it's
No,
harder for you to keep.
it's definitely helpful.
No, but I remember you had a problem last time of keeping track of all the problems.
Oh, you're
So
saying like keeping them.
I don't want you to be looking at 40 pages of scan, you know?
Yeah, I think that was my problem with the tests is I had like so many papers and I couldn't find like specific problems to go with that problem, you know what I mean? Because I was like going through all these papers. Um, but it's helpful to have it on the phone. I just didn't go on my phone too much to look for problems for the
Right.
test, which I
Well,
probably
but
should
I
have.
also sent that to your email.
Yeah.
You know what I mean? If it's the whole assignment, or if it's like lesson lecture notes or something
Hmm.
where I literally wrote the whole, then I
Yeah.
usually send it to your email so you can download it anywhere you want. You can print it if you want, or you can download it or whatever.
Yeah, I think that would probably be more helpful if I download it and then I could have it right there. Yeah, it's helpful the way you're doing it though on the printer or like
Yeah, I just didn't know which way would help you more. You know what I mean?
yeah, I think either printing it out I think would probably be better for me or
I
having
see.
it like yeah, right in my hands, but I know that's like impossible right now. So I can probably download it and then print it out or have
Well,
it.
that's what I'm saying. What if you just send me the homework?
Yeah.
Because you're having a lot of trouble on these sections. So send me the homework so
Hmm.
I can work it out.
Okay.
And then we can go over it. And then that probably will help you understand it. Because
Yeah.
you've always learned better by observing
Yeah.
others, and then you mimic what I get it. You've always done better like that.
Yeah.
So did you want to take a break or do some more or what?
Yeah, I'm just gonna take a bathroom break and then you said that you have something at 12 or
Around that time.
okay. Because you
Whenever
usually
lunch
have lunch, right?
whenever lunch comes, and then I have to call Doris
Okay.
and see what's going on with her English class, because honestly, I've been neglecting her the last couple of days.
Yeah.
But she had the essay to turn in, so I knew that she wasn't gonna have homework except to work on the essay. You know what I mean?
Yeah.
Now her final draft is due next week, so I have to figure out what else the teacher said. Besides, did you enter the one for the one we did?
Oh, No, I didn't. Thank you for reminding me that.
I don't have your screen share on because I turned my screen share off.
Oh,
So go take a bathroom break and then do
okay.
that. And I'll work
Okay.
on the next one.
All right.
Did it disappear? Oh no, she just logged herself out. 5y times the cosine of x squared times 2x first function times the derivative of the second plus the second equals 9x first function times the derivative of the second cosine y squared 2y dy dx plus 9 9 sine y squared. So then you get 10xy so you get 10xy cosine x squared plus 5 sine x squared dy dx equals 9 18xy dy dx cosine x y squared plus 9 sine y squared. So then you get 10xy cosine x squared
Okay. Do I have my screen shared or no?
no,
Oh,
not
I'm sorry. I forgot to do that. Okay. So
minus 9
let's
sine y.
see. I wrote this down as negative.
I have negative y,
Sine,
sine
right?
xy, over, so yeah.
Cos of y?
You have a negative in front of it? Oh, you do
Yeah.
have it in front. Cosine of y
Plus
plus x
x.
sine of xy.
X.
Mhm. Do you have a, yeah, it's going to take it, right? Yeah, it should.
Yeah. Yeah, it's good.
Okay. And then this one is a product rule with a, so I'm working on it right now. Let's see, 10xy cosine x squared plus, let's see, where am I here? This has a, does there anything without minus 9 sine y squared? Cosine y squared times 2. Okay, so this is minus 9 sine y squared equals, we have 5 sine x squared dy dx.
So is that considered 3 terms because it's 5 times y times sine of x? Do you take the derivative of each one?
Well, it's a, okay, so it's a product of two terms,
Okay.
5y and the sine of x squared.
Okay.
The argument of the sine is x squared. So it's
Okay.
a product of two terms. Remember, the sine of x squared is not a product.
Right.
X squared is a product, but the sine of x squared is a single term.
Okay.
When the x squared's in the argument, it's a single term. Now, when you go to differentiate it, you're going to differentiate it like a product.
Okay.
Negative. And then this is going to be, yeah, I should have written that first, plus 18 xy cosine y squared times dy dx. So then now I have um, 10xy cosine x squared minus 9 sine y squared over 18xy cosine y squared minus 5 sine x squared equals dy dx. So this is my derivative. Let me take a picture of it. up on the screen. So then, let's see, 10. Better lighting right here. Let's see if it came out. Let's see. It's not bad. Okay, I sent it to your phone. See if you agree with my answer.
Okay. It's supposed to be from the very top to the second line, plus sign x squared.
So the first function, it's plus the sine of x squared, yeah. So 5y times the quantity of the cosine of x squared times 2x plus the sine of, oh wait, that should be y squared. I wrote x squared by mistake. That should be y squared. I changed it, but because the argument of y of sine is y squared, right?
Mm-hmm.
Oh wait, but that's the second part. Never mind. That's on the left side. So on the left side you have first function is 5y.
Okay.
Second function is the sine of x squared. So you have the derivative of the first function is going to be 5y dy dx.
Yeah.
5 dy dx.
Mm-hmm.
The second function is the sine of x squared. So you have what I have after the plus, you have first. Then you have the first function, which is 5y, times the derivative of sine of x squared, which is cosine of x squared times 2x. Okay.
Oh, okay, I see.
And then equals, the other side is a product as well. So the first function is 9x. The second function is the sine of y squared.
Okay.
Is it making sense?
Yeah, so basically you applied the product rule with the chain rule in the beginning.
Right. Mhm. And then it was just a matter of rearranging everything after that.
And then, so like you said before, when you apply that dy dx, the terms that have the y, it stays with it.
Well, the term, okay, so if you're differentiating y with respect to x, implicitly you get dy dx. So 5y would, the derivative of 5y with respect to x is 5 times dy dx.
Okay.
right? The 5 doesn't change, but the
Mhm.
x changes.
Okay. Oops.
Minus 18. Yeah, cosine y squared. Mm-hmm. Minus 5 sine x squared. No, that goes on the
Oops.
bottom, not
I
on.
didn't mean to do that.
Yeah, I know the feeling. Google Docs does that to me all the time. Like, I didn't want to put you over there.
Yeah.
And then don't forget to close. Yeah. I don't know how particular it is about if you don't close
The brackets.
the
Yeah.
space.
I know it's weird because they have like a faint line, but it's still stays a faint line if you don't actually put it. So I just kind of expect it to
Well,
close
it's no, it's reminding you that you need to close a pair,
Oh,
and it's suggesting the most logical place for it to go,
yeah.
but it's not always the place where it should go. Kind of like when your phone suggests words that you're trying to spell, and you're like, I wasn't trying to spell that, and then you end up with a message that you can't read because it suggested all the words that you thought it was giving you. Okay, so dy dx by implicit differentiation. So this one says the square root of 7xy is equal to 4 plus x squared y, right? So I would change the square root to 7xy all to the 1/2 equals 4 plus x squared y. Then you differentiate each one implicitly. So this first part on the left side is going to involve a chain rule and a product rule. So we have 1/2 7xy to the negative half times the derivative with respect to x of 7xy. So the derivative of the first function is 7x, so the derivative is 7 times the derivative of the second, derivative of the first times the second, so that's y plus the first, which is 7x, times the derivative of the second, which is dy dx.
So you're taking the derivative of 7xy.
Right. Uh-huh.
And so you said you take the derivative of the first, which is
7.
7.
Because I'm using as my function, the first function is 7x. And the second function is y.
Okay.
So the derivative of the first function, the derivative of 7x is 7,
Okay.
times the second, which is y. Okay, so 7y.
7y.
So then the derivative of the second, the derivative of y is dy
Y.
dx times the first, which is 7x.
Okay, I see it.
Equals the derivative of 4 with respect to any variable is 0, so that's
0.
not going to change anything. And then the derivative of x squared y with respect to x. So again, product rule with the chain rule. So the derivative of the first function is 2x times the second, just like it is, y, plus the first x squared times the derivative of the second, dy dx.
So the derivative of 2x times y.
The derivative of x squared.
Oh,
So
x
you're
squared.
doing x squared y, right?
Yeah.
Yeah, so the first function is x squared.
Uh-huh.
The second function is y.
Y plus x squared times the derivative of y.
So I ended up with 2xy plus x squared dy dx.
How did you get 2x squared?
No, 2xy
Oh, 2xy. Okay.
plus x squared dy dx.
Okay, got it.
So then
Okay.
we're going to multiply,
The first two
so
terms.
we get 7 halves. Um, 7 halves. And then we have y over the square root of,
Are you putting y on the bottom, like radical xy?
yeah, I'm gonna put the 7xy under a radical at the bottom. So I have 7y over 2 root of 7xy plus um, actually they're both under. So I could do, I'm trying to see the best way for me to do that.
Okay.
The best way I can like manipulate that algebraically, because I'm gonna have to I have to separate the dy dx's out. You know what I mean?
Yeah.
And I think I'm gonna write it as this first, 7y times 1/2 7xy -1/2 plus 1/2 7xy to the -1/2 times 7x dy dx equals 2xy plus x squared dy dx. So I'm going to go ahead and, the terms that don't have a dy dx in them, I'm going to I have a So this term has a dy dx, and this term has a dy dx in it right here. So I need to move those together. So I'm going to have 7y times 1/2 7xy minus 1/2 minus 2xy is equal to x squared dy dx minus 7x over 2 times 7xy to the negative half dy dx. So then I'm going to get 7y times, okay, minus 2xy. Okay, yeah, so this is going to be 7y. What did I forget to do? 7y 2. Okay, so I'm getting, I have to simplify the complex fraction, but I'm getting dy dx. Maybe I could multiply by 2 right now. Dy dx I would have been better off doing that before, but I'm getting dy dx, so I have to factor out 7x over 2 over 7xy minus to the minus half plus x squared on the bottom.
Mm-hmm.
So I have dy dx, yeah, so the bottom is 7x over 2 times 7xy to the negative half. And,
You factor out an x, or would you just leave it?
well, I could. I just noticed that I think I should have just multiplied everything by 2, and that would have cleaned up the fractions. Now that I'm looking at it, let me see.
Mm-hmm.
Hold on. Let me do this again. So it's 7xy is equal to 4 plus x squared y. Did you leave the fraction, or did you?
Yeah, I left it as a fraction, but I'm seeing a common factor of a y on the top and a common factor of an x on the bottom. So I didn't.
Yeah, I was wondering. Yeah, I'm looking at that too. But see, I left the fraction, so it's going to make it complex.
Yeah.
And so I'm actually going to go back and
So you wouldn't be able to multiply it by 2 right now.
well, yeah, you can. But I'm gonna do it sooner and
Okay.
see if that cleans up the problem any
Okay.
in terms of, because when I FOIL, when I use the chain rule, I get 1/2 of 7xy to the negative half.
Yeah.
times
7.
7y plus 7x
Mm-hmm.
dy dx. And see, what happens is, because I have all those fractions, they all get distributed to all those terms.
Yeah.
And it just makes it messy. So
Yeah.
I have 2xy. On the other side, I have 2xy plus x squared dy dx. And if I multiply right now by 2 before I do all my gyrations,
Mm-hmm.
then I'm going to have 7xy to the negative half times 7y
Mm-hmm.
plus 7x dy dx is equal to 4xy plus 2x squared dy dx.
Oh, I see.
And it just keeps it from devolving into, I mean, it's still messy, but now I don't have to deal with I still have to deal with the root, but not you know what I mean?
Yeah.
So then I have 7y times 7xy to the negative half plus 7x times 7xy to the negative half dy dx equals 4xy plus 2x squared dy dx. And then when I move everything over, I'm going to move everything. It doesn't really matter. I think I'm going to move everything to the left. So I'm going to have, on the left, I'm going to have 7x times 7xy to the negative half dy dx, which is already there, minus 2x squared dy dx equals 4xy minus 7y times 7xy to the negative half. And then dy dx is going to be, let's see, I'm going to factor out a dy dx on the left. And that's going to give me 7x times 7xy to the negative half minus 2x squared over, equals 4xy minus 7y to the 7xy to the negative half power. And then dy dx is going to be equal to 4xy minus 7y times 7xy to the negative half over 7x times 7xy to the negative half minus 2x squared. Now, I don't know if they'll take it because of all the negative exponents, because I didn't deal with the roots.
Mm-hmm.
But that's what I have.
Actually, I have a question about that. The roots, like, since the bottom has a negative 1/2 on there, how would you deal with that?
Well, if you were to, let me take a picture of it so far, and then
Okay.
I'll show you how that. manipulation would go. Let me just check to see if I have a, oh no, that was CVS trying to call me. Okay. Uh-oh. So we have, whoops. Are you going into something else?
Yeah, I was just gonna see if they had like the actual, like the way they wrote it in Czech. Sometimes they have the um
Oh, okay.
like the correct format of it, you know? So I was
Well, it should take it, but it doesn't say anything about not using negative exponents.
negative. Okay.
Because, I mean, that's allowed in calculus. It's just, I don't know if they've
Yeah, because
done it.
I mean, I don't think it's wrong. I just know sometimes they have,
No, I understand what you mean. Totally. I,
although sometimes they don't have the right way to ask the question to see how it's not pasting right. No.
well, it's probably keyed to the textbook, so if you can figure out what number it was, then you can usually.
Yeah. Yeah, I don't see.
So if I were dealing with this, this would be a complex fraction where I would have dy dx is equal to a complex fraction where I have 4xy minus 7y times 1 over the square root of 7xy. And then I would divide that by 7x times
Oh, I see.
1 over the square root of 7xy minus 2x squared. So then I have two fractions with
Within there.
a root of 7xy. So then I would have to multiply, to make it work, I would have to multiply everything by the square root of 7xy. So I would have 4xy times the square root of 7xy minus 7y over 7x minus 2x squared times the square root of 7xy. And then if I wanted to rationalize, I could, which is
Yeah.
more or less the same thing that we wrote. It's 4xy times,
Oh, yeah, it took it.
yeah, it's just messy. Regardless of
Yeah.
however you do it, it's a messy answer. Like you can only clean it up so much. Like you can't make that look totally nice no matter
Yeah.
what you do. It's like that one we did with the cosecant the other day, remember? And it was just like, this is just going to look bad regardless of how much we try to fix it. Okay, so this one is actually asking you to find the derivative, but it's asking you to find the derivative at a point. So it says if f of x is, okay, so this is a little different. F of x, So they give you a function defined in terms of f of x. So if f of x plus x squared times f of x to the fifth power, and only the f of x is going to the fifth power, is equal to 34. So we know what that is. F of x plus x squared times f of x to the fifth is equal to 34. And f of 1 is 2. F of 1 is 2. We want to find f prime at 1. So, okay. F prime at 1. So, I need to solve the expression they give me. This equation up here that they give me that looks like they've given me a number, okay?
Mm-hmm.
This time, instead of giving me y, they've given me f of x, okay? So I need to implicitly differentiate this. So f of x, if I differentiate f of x with respect to x, I get f prime of x. So f prime of x.
Mm-hmm.
Now the second part is a product again. So I have to do product rule. So I do, the first function is x squared. The second function is the quantity f prime of x to the fifth power. Okay? So I do the derivative of the first function, the derivative of x squared is 2x, times the second function, which is f of x to the fifth power, okay? Plus the derivative of the second function. So the derivative of the second function is 5 times f of x to the fourth power times f prime of x. Okay?
Okay.
So then I have the derivative of the first is 2x times the second plus the second, times plus the derivative of the second times the first. So I've done the derivative of the second one. Now I have to do the first one. So that's, I'm going to multiply that by x squared, right?
Mm-hmm.
So I have, that's the second times, yeah, okay.
So the
Then,
last function, right? You multiply by x squared.
right, so I have 2x times the quantity of f of x to the fifth plus 5 times the quantity f of x to the fourth times f prime of x times x squared.
And you still have the f prime of x in the beginning, right?
Mm-hmm. Yeah.
Okay. And that's multiplied to the 2x, right?
So f prime of x plus, and then you have the function, because the first part is a sum, so I don't have to multiply the first f prime of x by anything.
Oh, I see. Okay.
It's that middle piece that has 4 terms,
Is
that
the
x squared,
product. Yeah.
yes.
Okay.
And then the derivative of 34 is 0. Okay?
Okay. That makes sense.
Now we're trying to find f prime at 1, right?
Mm-hmm.
So it says find f prime of 1. So everywhere you see an x,
You plug in
you're going to
1.
put a 1. So you get f prime of 1
Prime of 1
plus
is
2
2
times 1 times
f of
bracket
1
f of 1 raised
to the
to
5th
the
power.
5th power plus 5 times f of 1 raised to the
4th.
4th power times f prime of 1 times 1 squared is equal to 0.
You don't have it equal to 2 because it says f of 1 equals 2.
Well, I haven't put the 2 in yet.
Oh, okay.
The 0 came,
From
the
the
0 came
34.
because, yeah, from the 34. Now, I could go back and solve all this for f prime of 1 because I want to know what f prime of 1
Oh,
is. You know what I mean?
yeah.
We
So
know
you're
what f of
basically
1 is. We know what f of 1 is. We don't know
right.
what f prime of 1 is. But
Okay.
I'm going to clean it up first. So I'm going to say f prime of 1
Okay.
plus, I'm going to clean it up as much as I can. 2 times 1 is 2.
2,
F of 1, they give us.
which
F
is
of 1
2.
is 2. So I have 2 times F of 1, 2 to the 5th
2 to the 5th plus 5,
plus 5 times F of 1 to the 4th. F of 1 is 2.
2
So
to the 4th.
2 to the 4th times F prime of 1. So see how all of that's going to become a coefficient later?
Right.
Times 1. Because 1 squared
Okay.
is 1.
Got it.
It's just easier, I think, in this case. Not most of the time, but in this case, it's too easy to mistake a prime for a 1 and a 1 for a prime. And
Yeah.
so f prime of 1 plus, now let's fix this product in here. We have, we got to follow the order of operations. So we have 2 times 2 to the 5th, that's going to give us 2 to the 6th, which is 64.
Mm-hmm.
Plus 5 times 2 to the 4th is 16. 5 times 16 is 80.
80.
So we have 80 times f prime of 1 times 1. See how much easier that got?
Yeah.
And that's equal to 0. So now I can solve for f prime of 1 because now I have f prime of 1
Mm-hmm.
and I can say, I can drop some of the brackets. So f prime of 1 plus 64 plus 80 f prime of 1 is equal to 0.
Mm-hmm.
Now solve for f prime of 1. Well, the only thing I have to move is the 64. You see that?
Yeah.
So then I have 81 f prime of 1. Do you see that?
81.
Well, because f prime of 1 at the beginning plus 80 f prime of 1 in the middle gives you 81 f prime of 1.
Because I had it multiplied.
Well, 16 times 5 is 80,
Mm-hmm.
and you're multiplying that by f of 1, but you're not multiplying the initial 64 by anything.
Okay.
It's 2 times 2 to the 5th plus, so, here.
Maybe I wrote that wrong.
It's very possible. I feel for you. I was trying to make it as, it's not as hard as the last one, but it's easy to get tripped up in the notation here
Yeah.
because it's all ones and primes and it's just a mess. But it's not as messy as the last one that we had. See if you can. It's coming right now.
Okay.
You should get it in about 10 seconds. It's sending it. And then what I get is 81 f prime of 1 is equal to negative 64. So then divide by 81 and we get, can I simplify?
So when
No.
you so when you have the 80 of the f prime of 1 plus the f prime of 1, that becomes 81.
Yeah, because 1 f prime of 1,
Yeah,
because the f prime of 1 is like 1 f prime of
like
1.
1. Okay. I wasn't looking at it like that. Yeah, that makes sense.
So I get f prime of 1 is negative 64
Over 81.
over 81.
That can be simplified.
I know, I had the same, I did, but it's not, because that's 8 squared and the other one is 9 squared. And the
Yeah,
other, if we were taking the square root, we could,
yeah.
but not here.
Okay.
The fraction itself doesn't
Okay.
simplify.
Enter fraction. Okay.
Yeah, okay. Integer, okay, see, they do give you some directions,
Yeah, when
but not like Pearson where they go nutso and tell you.
it at first confused me because normally they give you that bar and then the bar
Oh,
disappears and then it tells you write it in a fraction. But I'm like, where's the fraction? So you have to put a dash in between like that.
you can use the little divider thing, right?
Yeah, that's what I use. But at first I thought maybe it wasn't gonna take it when I first
Oh,
tried,
uh-huh.
Yeah, so it takes it.
Now here, okay, so here we're going to do the same thing, but they're going to mess with our head. Because now we're going to do the same thing, but we have like multiple product rules in here. And we're going to reverse the process. So instead of dy dx being our function, we're looking at dx dy. So now the derivative of y with respect to x will be implicit and need a chain rule. And the derivative of anything with a y in it won't need that. So it's the reverse of what we were doing before.
Okay.
So it's implicit differentiation the other way, because now x is a function of y instead of y being a function of x.
Okay.
So we have to be really careful. So here we're looking at dx dy basically. So we have x cubed y squared minus x to the fourth y plus 2xy cubed is equal to 0. Now we have, this is 3 separate products. So we have to apply the product rule 3 separate times.
Okay.
Okay? So this is going to be d dy of x cubed y squared minus d dy, and I just wrote x, d dy of x to the fourth y plus d dy of 2xy cubed 2xy cubed, and then d dx of 0. So,
Or dy,
when,
right?
yeah, sorry.
No, you're fine.
So then when I differentiate this, the derivative of the first function is x cubed. So that's going to take an implicit derivative. So I'm going to have the first part of the first product is going to be 3x squared dx
X, T.
dy. So the derivative of the first one times the second one, so times y squared, plus the first one, okay, wait. See, I have to do it backwards from the way I normally do it, so I don't confuse you. So
Would be X cubed.
so now I need to take the derivative of the second one,
Yeah.
and that one doesn't have any, so that's just going to be 2y, and then I have, thank you, more noodles. I'm going to be so lucky. So the second one is, I lost my
Of the 2y.
train of thought here. So we have 2y, and then I have to take the derivative
Of x cubed.
and I multiply that by x cubed. So it's
So the 2y is, it doesn't get the dx dy next to it?
not here, because remember we're differentiating with respect to y now.
Yeah.
So the one with the derivative on it now is the x, because we're going the opposite way.
So the x cubed just stays the same because it's not taking the derivative of it. Okay, that makes sense.
Yeah, does that make sense or not?
Yeah.
So it's the first function, which is x cubed, has the derivative of the second one, which is
3x squared.
2y. Okay, so
Oh, are you on the second one?
I'm doing
Sorry.
the second one, but I think 2y.
So the second one is the x to the
I
fourth.
should have a 2y, and wait.
Yeah, because
2y.
I think you're looking at the third one, but we're supposed to be looking at the second one.
There's only 2 of them, Sam.
No, there's 3.
The 3 functions?
Well,
No,
I
there's
mean,
only 2 terms.
yeah, only 2 terms. Sorry. But we're now looking at the x to the fourth power y.
Okay, yeah, no, I know. But do you
Okay.
the first one? I was still looking at the first.
Oh, sorry. You are multiplying them together.
Yeah.
Okay, because when you said 2xy, I thought you were on the third one. Sorry.
No, so then, okay, that's the first product rule, right? Now the second product rule, put a minus, and we'll distribute the minus later.
Okay.
So it's the derivative of the first one. Now the derivative of x to the fourth with respect to y is 4x cubed dy dx.
Or d
dx dy, sorry.
dx dy.
dx dy. 4x cubed dx dy.
Okay.
Then you take the second one and leave it alone. Then you add, and now you're going to differentiate the second one and leave the first one alone. So it's x to the fourth, and the derivative of y with respect to y is 1.
1.
So there's a 1 there. okay?
Okay.
I'm thinking I did the first term wrong, but I have to go back and look at it. Now the next one is going to be, the first function is 2x. So we have the derivative of y with respect to 2x is going to be the derivative of y, hold on. The derivative of y, the derivative of 2x with respect to y is 2x. I think I wrote this backwards.
Times y cubed.
Yeah, but the derivative of 2, the problem is I wrote it backwards from the way the problem is written. So this is d dy. So then this is going to be 2x times 3y squared plus y cubed times, it's going to be y cubed times 2x, it's y cubed times 2x dx dy. 2x dx dy. And then you have
Plus 2. Okay.
2x times 3y squared. And so the first one still bothers me. I think I have too many x cubed y squared. So it's cubed y squared. And I'm differentiating with respect to x, with respect to y. So I have x cubed 2 pi dy plus the second function y squared times x cubed x dy.
So I have a question. When you're done.
Wait, it's still, go ahead.
Okay, so because we're taking I'm still trying to understand the derivative part where it's dx dy of an x
So
term.
now, yeah, so you're probably better off if you do it separately like you did on the other one. Where, remember I showed you the derivative of y
Yeah,
with respect to x and the derivative of y with respect to y. That's kind of what this is, except it's reversed.
because when we were normally doing dy dx and then we had a y term, the y's would
dy dx of y
yeah,
is dy dx.
of y is
dy dx of x is 1. So when the bottom letter of the derivative matches the function, it's 1.
okay. So in this case, it would be whenever there's a Y.
Right. Then you're going to get 2y or y or 1 or whatever.
Okay.
So it's probably better if I do, like, if I set it up this way. So when you, instead of doing what we just did here, let me do this another way. So the first term is x cubed y squared, right? And we want to find d dx of x cubed y squared. So that means that our first function is x cubed, and our second function is y squared.
Mm-hmm.
Second function is y squared, right? So then the derivative of the first function, I'm going back to the first term. The derivative of the first function with respect to x is going to be 3x squared, okay?
Okay.
Because remember, we're differentiating with respect to x, right?
Yeah.
The derivative of the second function is, with respect to x, the derivative of the second function is 2y dy dx,
Okay.
okay? So then, when you do the product rule says, the derivative of the first times the second plus the derivative of the second times the first, okay?
Okay.
So then you get the derivative of the first is 3x squared. The second one is y
Y
squared,
squared.
plus the derivative of the second one with respect to x is 2y dy dx times the first one, which is x cubed. So the first term is, the first product, I should say, is 3x squared y squared
Mm-hmm.
plus 2y dy dx times x cubed. You see
And
that?
you wouldn't combine those then?
No, because one of them has a dy dx.
Okay. Right.
So why don't you, I
Okay.
have to eat lunch right now.
Okay.
So let me eat lunch. Let me call Doris,
Okay.
and I'll work on this one and the other one that we, and what time would be, are your kids gonna be home today, or
Yeah,
what,
I'm not sure because
what's
my
the schedule?
husband, mom, my husband has to work late, and so he has my car, and I don't really know um what time they're either getting dropped off here or I have to find out, but I'll let you know as soon as I find out.
Yeah, just text me so I know, because I can always set up another meeting or whatever. But it looks like we're, what, halfway? Almost?
No, this one's really long. It's a lot longer than the other one. I think this one said it had 20,
Oh, wow.
Oh no, it has
Only
16.
16. So yeah, we're about halfway.
Yeah. Maybe it's the other one that's longer. I'm not sure. Yeah, but we did get a lot done. And 2.7 has less questions. So, oh, it has 6, but it's
But they're like
a lot longer
they're
question.
like 8 parts. I know.
Yeah. So we're
'Cause I remember,
making progress.
'cause I remember doing this section in the textbook
Mm-hmm.
when I was doing it in the textbook, and she only assigned like 6 problems, but it took me like 10 pages to do the homework.
Oh my gosh.
And I think it took me about 3 hours
Yeah.
because they all had like 8 parts to them, you know?
Yeah. Yeah.
They weren't,
So,
most of them weren't that long, but if you send me the,
yeah, I can work on sending it to you.
yeah, just send me the PDF so I can work
Okay.
the rest of them. But I think when I have products like that where they switch them, that I think I'm going to write out the functions for you.
Mm-hmm.
So you can actually do the separate derivatives and then put them together after that.
Yeah, I'm not sure that it doesn't look like they have a
Yeah, it does. But open up the window to full because it's not on full right
yeah.
now.
Yeah, it's on full.
An assignment right here.
Oh yeah. Yeah, like before I just printed it and then I just sent it to you through
Yeah,
my okay,
yeah.
so
Just
that like that.
print it, and then you can convert the file to
Okay.
PDF or whatever.
Okay. I'll do that. All right. Thank you so much.
You're welcome. Sorry to have to stop you right now.
Yo, you're fine. I think it was a good place to stop so then I can wrap my head around the concept a little more.
Yeah, it's a little bit bumpy,
Yeah.
but we'll
I
have
mean,
some time.
I feel like I'm getting um it's making a little more sense for me. It's just there's so many different ways, or different variables. I guess I
Right.
need to
No,
look out for.
yeah, exactly.
Yeah. It's like, when do I apply the product or when do I not? So that's
Yeah,
what I
I
have
get
to
it.
work on.
Okay. I'll try and make some notes on it, but we'll see what happens, okay?
Okay.
I'll be in touch later on, Sam.
Okay.
Take care.
You too. Bye.
Bye.